Hey guys, in this video I'm making this very simple 2-control 1-transistor delay pedal. So this week I got a handful of these things in, little modules. It's a PT2399 module. That refers to the chip on the module here. It's a PT2399. It's a chip that came out in the late 90s, and it's kind of a self-contained digital audio delay. It's been used in loads and loads of pedals, certainly since the early 2000s. I started seeing it in sort of DIY stompbox designs. And it's been used in a few mainstream pedals as well. The Dan Electro Fab Echo is probably the best known one. I think that range came out in the mid-2000s, something like that. So it's been used in lots of pedals, even though it was originally designed for stuff like karaoke machines and surround sound systems. And I guess that first generation of mixing desks and stuff that had onboard effects. So the chip itself is not exactly what you'd call plug and play. Just to make it into, or just to turn it into a simple echoed circuit, you're going to be putting 20-25 parts around it. Plus, of course, it'll need voltage regulation as well, because it's a 5-volt chip, and obviously we're powering our pedals with 9 volts. So the nice thing about these little modules is that all of those parts are kind of already there, and you get a basic audio echo circuit. It's more or less the same circuit that's in the original data sheet. It's not identical, but very close. And it even has onboard voltage regulation, which is that little guy there. The other nice thing about these is that they are dirt cheap. I bought 5 or 6 of these, and they work out at about $3 US each, and that included postage. They're all over eBay and AliExpress, so they're very easy to find. It even comes with an onboard pot, although unfortunately it's pointing the wrong way to be made into a pedal, so I'm going to have to desolder that and use another pot, or place this sort of pointing in the opposite direction. This pot is a feedback pot, and you can also mod this pretty easily to have a control on the delay time, but I'm going to show you that later on. I think the first thing I want to do is just plug this into my scope and run some signals into it and just get a sense of how to turn it into a really basic delay pedal. Fairly sure this is designed for line level signals, low impedance signals, so I think at very least I'm going to have to put a buffer up front. So the first thing I notice when I switch it on, well, it's got a cute little red LED on it, but aside from that, you'll notice that the output, which is this blue trace, is floating. You can see it just falling into place there. So I'm going to have to put some kind of resistor on the output. The other thing I notice once that settles in is that the output is out of phase with the input. That's not really that big a deal. It's kind of an unwritten rule with pedal designs that the input and output of your pedals should be in phase, but 99 times out of 100 it makes no difference. However, there are times when you put pedals in stereo setups, or parallel effects, and it will give you headaches. I'll keep that in mind, but I think for this build, where I just want to keep things as simple as possible, it's going to be on the bottom of my priorities. The other thing I've noticed is that this blue trace, which is the output of the module, is actually just a hair hotter than the input. So I just did a bit of maths on this, and we've got about a dB, or just around about 1 dB of boost through the module. You almost certainly won't hear that, but the nice thing is that again, keeping the pedal simple as possible. I won't need a volume control. If I just want the pedal to be unity gain or very close to it when you click it in and out, that's a nice thing. I won't really need a volume control. So I've got a pot rigged up in line, and I'll just wind up its resistance until the output wave's half of what it was, which is round about there. And I'll just measure that pot. Yeah, so the input impedance is only 12 k ohms, so the guitar signal is definitely going to need a buffer. So I'm just running a bode point plot, and where's that? We've got a roll off happening. Yeah, we're at about 8 kilohertz or thereabouts. With any other audio device that wouldn't be acceptable, but with a guitar pedal, a roll-off at 8 kilohertz is absolutely fine. A guitar is really not going to produce much above that. I think that's okay as well. So I've been scribbling out some of the most common input buffers for pedals and stuff. This is an inverting op amp. This is a non-inverting op amp. This guy here is what a lot of the Boss pedals from the 80s and 90s, those classic pedals, had, which is a single bipolar transistor. And this guy here is using a simple single FET circuit as an input buffer. These all have pros and cons, and maybe I'll talk about that in another video, but weighing it all up, I think I'm going to use this guy, the single FET. It has a very low parts count. It's a very simple circuit. I think I can make it on a really nice tiny piece of stripboard, which will fit in to my little box somewhere. If this was a standalone circuit, you would need things like this guy here, which is a polarity protection. I've looked over the board and I can't actually see a polarity protection diode on it, so I am going to run with one of these. You'd also use a decoupling cap, but the board actually does have this huge 470 mic decoupling cap, so I think what I'll do is actually run the power for the buffer from the board, but I will run this diode in line with the wire from the DC jack. The other thing you would do, of course, if this was a standalone circuit, is you'd have an output coupling cap like this, and then some kind of resistor if it was electrolytic to pull it to earth. The input coupling cap on this guy, which is, where is it? It's that guy there, is a 10 mic electrolytic, and its negative side is actually going to the input. So it's tempting just to get rid of that altogether and run this straight to that coupling cap into the module. Problem with that is that this node is going to be something like 4 volts, give or take, and the other side of this into the module is going to be probably 2.5 volts, I'd say. That would mean that this guy would be at 2.5 volts, and it means this input coupling cap's not going to be happy with that. So I mean, you could desolder this and flip it around and resolder it, but it's a lot easier just to run with our original idea of having a decoupling cap and then just hook that straight up. I'll use a 10 mic cap, and when you have two 10 mic coupling caps with their negative wires hooked up together, essentially what you have is a 5 mic bipolar or non-polarized cap, and you don't even need this resistor in here. It'll work just fine that way. Alright, I've done some stuff. This scribble has been now replaced with a nice neat schematic. Here's our FET buffer right here. 2N5484 is a really common FET, it's easy to find. In fact, in Australia you can buy it straight over the counter at JCar. Here's our output resistor I was talking about to pull the output coupling cap, which is that guy there. Pull that down to earth. I'm actually going to mount that, I think, on the stomp switch. I've also created a tiny little stripboard layout for the buffer. It'll be about 2.5 centimeters long and about 2 centimeters wide. It's just got the one cut in it, so it's very quick and easy to make. Notice I've laid my output coupling cap down on its side, so I'm going to, instead of mounting it up like that, I'll be mounting it on its side, because I really want to keep this as low profile as possible, because of the way I think I'm going to have to mount it in this little box. Also notice that there's a jumper here that will have to go underneath that cap. Now the PT2399, its delay time is, well, its internal clock, which controls the delay time, is controlled by the resistance between pin 6, which is that guy, and earth. And this module comes with a fixed resistor there, R27. I think it was a 15 k ohm resistor. But if you flip over the board, I don't know if the camera can catch that, but there's also a track running from pin 6 over here to these solder pads. There's a little row of 3 solder pads. One of them is labelled S, which is pin 6. I'm not sure what the S stands for, but right next to it are 2 more which are connected to earth, labelled G, I guess, for ground. So obviously whoever designed this board thought that the end user was likely to want to put a pot in there to have an adjustable delay time. So it's kind of already set up, but you do have to remove R27. Removing surface mount parts, especially these are 0603s, so these are, even by surface mount standards, these are pretty tiny. But don't be scared of it. It's actually pretty easy to remove a resistor like this. You just basically lay your iron on top, touch it with a little extra solder until both sides of the resistor are molten, and then you can just kind of sweep the resistor away. Then I recommend obviously checking under a magnifying glass that you don't have any solder bridges or anything there, or you haven't damaged the board, but it's actually easier than it sounds. I think this footage is a bit out of sync, but here I'm desoldering the power terminal block so I can use soldered wires instead. And as I mentioned, the existing feedback pot needs to be removed. I've also removed the input and output signal header pin connectors. Not strictly necessary, of course, because you can solder leads to them. But I decided to use the earth via on the output connector for the delay time pot, which you'll see in a sec. This pot is loose, but its legs are quite a snug fit here, so I'm just gently wiggling it free. This is where a decent solder bolt type pump is really necessary. Those little thumb press spring-loaded solder syringes just don't have enough power for these type of tight-fitting vias. Being careful here to cut and deburr these pot shafts so these little red knobs will sit properly and look right when installed. You're not really supposed to blame your tools, but boy, this soldering iron tip really needs replacing. Unfortunately, I can't find them the right size for this iron. It's about 20 years old, so it might be time for a new solder station, I think. But I will keep looking because it works perfectly otherwise. I'm running wires for input and output signal, plus an earth and a 9 volt. These 3 lengths of hookup wire are obviously for the new feedback pot. Some short lengths of heat shrink so they don't short when they cross over. Here's that earth wire for the delay time pot. Just pushing that 2.2 k ohm resistor into the pin 6 solder pad, the one marked S on the board. I'll reflow that joint from the other side in just a sec, but first I'll just hold that resistor in place with a drop of hot glue. Soldering this, I realised that the pot on the schematic is actually shown upside down. I'll fix it for the PDF. It doesn't really matter, it just, I think, makes more sense though to have the pot anti-clockwise for short delay times and vice versa. Here I'm cutting the track in the wrong spot, but after I checked the layout I realised I didn't have to remake the board after all, since the cut can actually be in one of 2 spots. When you see the layout, you'll know what I mean. Here I decided to lay the input coupling cap on its side as well as the output, just to keep the board as low profile as possible. But in the end, I didn't need to do that. The space created by the pots between the top of the enclosure and the bottom of the module, there's plenty of room there for the little buffer board. Got to make a note of all those wire colours because I'm going to put some heat shrink on this little guy so I can tape it up to the top of the box underneath the module. So yeah, there's plenty of room for the buffer board under there, and there'll be a couple of shake-proof washers on each pot as well, which will create even more space. For quick one-offs like this project, as you can see, I just hold the box in one hand and the drill in the other. I've got a lot of experience with hand tools and I'm comfortable doing it like that, but if you're new to this, I'd recommend clamping the enclosure to your bench so you can guide the drill with both hands. And it probably goes without saying, but a center punch and some fresh drill bits will make your life a lot easier here too. So once the enclosure's drilled, I can look at the fitment of the jacks. I had to file a slight chamfer on opposite edges there so I could slide the jack in at an angle. I'll do something about those lugs in a sec, but now I can mark and drill a stomp switch hole. First I worked out which lugs I'm actually using, and once I'd nipped off the others, the jack lugs didn't interfere at all. So now the jacks are prepped, I'll do a quick test fit and then move on to the artwork. Originally I sprayed the box white as an undercoat, but I went for a coffee and I really like this cat design on the cup I was given, so I scanned it and then rearranged it in Photoshop, and yeah, I think it looks pretty cool. Then I printed my design onto clear decal paper and gave it a couple of light sprays with clear coat to seal the ink. There is a bit of a knack to using water transfer decal paper. There's already loads of how-to videos on YouTube, but for me, the two things I'd recommend is firstly, set your printer for glossy photo paper and also on the highest quality print setting, which will also be the slowest of course. My inkjet actually pauses slightly every couple of passes on this setting. I guess that's to avoid smudging the fresh ink. The other thing is really, I guess, to know your materials. Those little in and out labels only needed a few seconds in the water, but the main label, probably more like 2 or 3 minutes. Too long in the water and the decal will just float away off the backing, and even if you can gather it up and place it, the glue will have dissolved and you won't really be able to fine-tune its position. It was right about now that I thought I probably should have called it Coffee Cat instead of Copycat, but oh well, next time. I was just about to clear coat this when I realised I'd forgotten to take out the decal from the holes. Would normally do this before I tape the handles on, of course. Here's a top tip: if the weather's cold or your can is getting low, float it in a bucket of hot water for maybe 10 minutes before you spray. You'll get much better pressure from your rattle can that way. That's a tack cloth, and really another top tip right there. Use one just before you spray and you won't get those little bits of dust that create those little nits in your finish. You might be able to hear this can is kind of stuttering a little bit because it is getting old, so I'm careful to start it off to the side before I make each pass. So after 2 or 3 good wet clear coats and an overnight drying time, it's on to the final fitment and wiring. You can get LED mounting bezels, but I personally just prefer to glue the LED in from behind. Just think it looks a bit neater that way. This is a multi-purpose solvent glue, but gel super glue, 5-minute epoxy, even hot glue would probably work, to be honest. Just using a bit of blue tack there to hold the LED in place while that glue dries so I can keep moving. On the schematic, the 3 stomp switch poles are shown in the on position, so numbering them like that just helps to avoid confusion. When I'm wiring a pedal or a bass, or loading a circuit board, say, I never have the radio or a podcast on or anything like that. You really do have to concentrate with this sort of stuff. Just misreading the colour band on a resistor or something can lead to hours of troubleshooting. I still make mistakes like anyone though at times. With this pedal I actually forgot to connect the wires to the jack tips, so I had to actually remove the stomp switch at one stage to get access to the lugs. There's that 100k earth resistor for the output coupling cap. So now I'm just gathering up all the earth wires. I'll twist them together, tin them, and just solder them to the sleeve connector on the input jack. That way the enclosure is earthed as well. Yeah, well, that sounds pretty good. I reckon for the next build with one of these modules, I'll add some filtering to the delay signal, maybe a low pass filter, and probably a wet and dry mix. I think that'd make a really interesting build. More complex though. I really wanted to keep this as simple as possible. I did actually have to tweak the circuit slightly. The pedal, well, not anymore, but the pedal had a little bit of switch pop. I have actually tweaked the circuit slightly. I've also added a little filter to the front end of the buffer. It's only two more parts. I did want to keep it as simple as possible, but it's only 2 parts. For this one, I just kind of hacked my existing board and laid those parts in a kind of creative way, but I have actually redesigned that strip board, so keep an eye out on my website for a PDF with the refreshed schematic and that new strip board layout for that little buffer. I'm going to call it a 1 transistor delay pedal. It's probably a bit cheeky, of course. The PT2399 has thousands of transistors in it, but as far as the build goes, yeah, it is really only 1 transistor you have to use, that FET, and it is a pretty simple sort of project, so give it a go. Really the only tricky bits were just the way I mounted the pots and dealing with those jack lugs that were interfering, but that's just because I wanted to use such a small enclosure. If you use a standard size pedal box or even one of these sort of things, you can mount the module in a conventional way and you won't have to worry about any of that sort of stuff. So thanks for watching. It's a great project, give it a go. Hope you enjoyed the video, and if you're new around here, do consider subscribing to the channel and hitting the bell, of course. So thanks for watching, and I'll see you in the next one.